Yeah, let me start. And still we are running with what exactly, no? Yeah, it's like 89. And maybe we are going to close today. And what we're doing is one hot encoding with ML actually. With ML, we'll see the term practically. When I say ML with algorithm, we are going to see. Okay, so even I can maintain yesterday examples so that you can understand very quickly. Fine then. Let me give a small recap. Let me take a small recap. Tim, whenever you're talking about the data, so even yesterday I have covered the data, especially you are working with regression kind of problem. Understand the data, either it is linear or non-linear. Either it is, if it is linear, you can just try to straight to the point, go to the simple linear regression and you can apply. That is valid. But if it is non-linear, first 2 point you should not apply linear regression. First 2 point you should not apply. Then Daniel, what we need to do? Check the alternatives. We would have other alternatives also, right? How we will come to know, Daniel? Either the data is a linear or non-linear. There are two ways. The first one, try to always plot the data. Try to always. Then from that plotting, you can understand how the data is traveling actually. Either it is a kind of some straight line, either it is a kind of some curve shape actually. You will get a clarity. If the data is traveling like a straight line, then go and you can just try to apply for simple linear regression. Regression you can apply. But if the data is traveling not like a straight line, the data traveling shape I have observed like a curve shape actually. First 2 point, don't apply linear regression. What exactly? Don't apply linear regression. Good. Now let me tell you. What do you mean by polynomial regression? What do you mean by polynomial regression? What do you mean by simple linear regression? When I say simple linear regression, we need to create a model. Yeah. So we need to create a model. Model equals to linear regression. First of all, we have to import the model. That step I kept hide actually. That is still okay. Yeah. The next one will be after model creation. You need to call a fit method. I mean, linear regression, we have to train with feature. We have to train with feature. Now, what do you mean by polynomial regression? Polynomial regression means linear regression only, but small change. What is that changes? While you are training, here you need to provide the feature, but here in a polynomial regression, while you are giving training, you need to train with what exactly? Polynomial feature. Make a note on this. That's it. No difference actually. Okay. Now, if you want, I can still help with the same steps. It's like a simple linear regression only. If you're able to understand that step, we are done actually. We are done. Okay. Now let me take a control. Till here I covered, I guess, yesterday, right? Now let me continue today. Plotting the data set. So quite interesting, and make a note on this one. Yeah. This is the continuation from yesterday's session, plotting the data set. Sir, get the data set too. Yeah. Now, step number 1, always importing the libraries based on your problem actually. Based on the problem statement, you have to import the required libraries. Yeah, Daniel, we're importing pandas for data visualization. I'm sorry, man. Loading the data, data analysis, data manipulation. Matplotlib for data visualization. sklearn for machine learning actually. Then step number 2, loading the data set. What is the step number 2? Loading the data set. Yeah, we are loading the data set. And if you want, maintain one small step here, like, done actually, so that you will get a clarity. Step number 1, step number 2, done. This you can understand, sir, quickly. Yeah. Importing the libraries and loading the data set. What is the next step actually? Data preparation. Data, what exactly, sir? Preparation. Let's do that actually. If you want, let me maintain the steps. It will be good practice, Daniel. Print off. At least the steps I can maintain. Topic. Polynomial regression. Step number 1. Step number 1, importing the libraries. Step number 2, loading the data set. Yeah. Move to the next one. Data preparation. Step number 3 is what exactly? Data preparation. Like a steps wise we are doing, sir. This is really great practice actually. So we are not even missing any step actually. And x equals to data preparation in the sense, especially I'm talking about input and output, x and y. What I'm talking, sir? X and y. Here I'm using ILOC. Here I'm using ILOC. But there are many ways to get that data into the shape actually. Okay. Yeah, almost 3 steps we done actually. Importing the libraries, loading the data set, data preparation. We are good to go, man. Fine then. Get ready. What is the next step? Any idea? Splitting data set. Let us make it an optional. Splitting data set. Let us make it like optional actually. Step number 4, splitting the data set. Step number 5, model creation. Let me create the model. Model equals to linear regression. Model equals to linear regression. We'll do one thing. Sir, actual story is going to start now actually. All right, it one is a model creation, right? Linear regression. Then let us train the model also. You talk with me, either it is a linear regression or polynomial regression. Very good. You understand the difference actually. By looking at the step, you should get an idea. Model training. Model dot. Do you think X train actually? X comma Y. Linear regression. We done. Then this one is a wrong. I mean to say. First of all, the data is a non-linear data. Madam, what data? Over non-linear data, how you can apply linear regression? We should not apply actually. Here is the story. We'll do one thing. Anyway, the model is ready, right? Let us create a plot. Let us create a plot actually. A special step we are doing. Ensure that make a note on this. And if you want, I can take it. These are all steps actually. I mean, no. Let us include directly plotting step. You know, these are all. Daniel, this step is important. Special step. Data visualization. What is that one, sir? Data visualization actually. Now here is the story. Come on, sir. What we are doing actually? Any idea? We are creating a scatter plot. We are creating a input and output we are giving actually. Kada? Now let us just have to provide, and you can just have to provide plot. I can talk with you later. You can just have to do these are all things. We already created even yesterday. These are all linear regression, kind of some positional values, and this one positional levels and salary. Look at the diagram. I would like to create one small folder for images actually. Get ready to understand. Yo, I have closed that image. Sir, first of all, image number 1. Let us maintain a image number 1. Just we are plotting. Go to the image and we are plotting. How the data traveling? First confirmation, curve shape actually. Let us apply linear regression. Let us plot actually. If you wanted to plot the linear regression, what we need to do, you can just have to take plot means create a line. Plot means create a line. Existing input only you have to take. But output you have to take a prediction value. When you will get a prediction value, get the model and provide X actually. Provide what exactly mean? X. Right. You can just have to come here. Daniel, can I plot line over the data? What do you mean by regression first of all? The regression means draw a line over the data. Talk with me. Over the data. How to draw actually? Existing input only how to take actually. Existing input only. Now here model dot predict of what we need to take, sir. Directly X you need to take actually. Very good. Now let me specify the color and red color I'm providing. It is okay. Sir, did I miss anything? Oh, sorry, man. Sorry. Let's run actually. Image number 2. Daniel, the model is directly telling, I'm sorry, I know this one is a non-linear data. You have applied linear regression. You have applied image number 2. Image number 2. Maintain clarity, sir. What is covering? You should have an idea. Come to the images. Image number 1. Image number 1. We are plotting. We are simply what exactly we are doing, this is without plotting. This one is with plotting actually. Okay. Get ready, sir. Take this code. Now here is the story. We confirm that this model is not a good model. I mean to say non-linear data. What data? Now I'm planning to create a polynomial regression. I'm planning to create a. When I say polynomial regression, first of all, get ready with the polynomial features. Get ready with. Then you can train with polynomial feature. You can train model with what exactly? Polynomial. Are you clear or not, sir? Let's move on. I'm planning for, polynomial regression. I'm planning for polynomial regression. This is the continuation session from yesterday. Polynomial regression. Polynomial regression in the sense, first of all, create a features. Create what exactly? Features. Then, so train the model. Train what exactly? Model with. Create a, polynomial feature. What feature? Polynomial features. From existing features. Then train the model with, chaptara sir, polynomial feature. Is so called as a polynomial regression. Is called as polynomial regression. That's what you need to be get a clarity. Let's do that one very quickly. I will explain in according to the order. Then let's move on. We even done prediction yesterday. This one is with regression we done prediction. Am I right or not, sir? With linear regression we done prediction. 3 lakhs ఎంతండి? 3,30,000. ఓకే. I have created one small new level actually, 6.5, and the score will be I'm sorry, not the score actually. 1,50,000 to how much I need to give actually? 2 lakhs. In between I need to provide actually, kada? But how much we are getting, sir? So the model prediction is చెప్పండి sir, 3,30,000 on an average. This we are getting actually. I'm sorry, wrong prediction actually. How can I give salary? The one who is having just senior to this guy, senior to this person, junior to this person, I should maintain some standards. Then only there is a consistency and no problem with the employees actually. Imagine this employee have revealed the salary to other guy, definitely it impact. What impact? He will put the paper immediately. He will also put the paper immediately. Put the paper in the sense he will resign. I will get a good salary in other companies actually. This guy is getting good salary in the company. Then why I will not get actually? Then so it impact actually. Wrong prediction. Let us do the right prediction. Let us do what exactly? Right prediction. Make a note on this one. Let's create a polynomial features. First, let us create a polynomial feature, sir. Get ready. I can just try to delete these are all what are not required. Then I can reinitiate later actually. Okay, these are all steps not required as of now, Daniel. These are all steps not required. Till here it is a common. Am I right? Children, sir, importing the libraries, loading the data set, data preparation. Talk with me. Now in my hand feature, what is the next step actually? Create a polynomial feature. I can make it like a special step number 1. Creating polynomial feature. What happened, sir? I didn't understand. I will import. Thank you. I will import. Once if required, then we can import actually. Special step number 1, creating polynomial feature. To create a polynomial feature, you can just have to create an object for this. Yeah, Daniel, we are creating an object, polynomial regression. Polynomial regression object name is. Then you have to import this one actually. What is the class name? Polynomial feature. Yesterday I covered actually. Overall missing yesterday session. Sir, ensure that yesterday session you missed a lot actually. Let us bypass now, sir actually. If anyone missed out yesterday's session is very, very important actually. Very, very important. Then at least you cannot miss next session actually. No, it's not yet created. Then you need to call a method. Method name is, what is the method, sir? Fit underscore transform. Daniel, object is ready. Now creating a polynomial feature. Now it is happening. Take that object. Over that object, you need to call a fit underscore transform. X you need to provide. Yeah, sir. Let me show you. First one, let me print data frame. Let me print X underscore poly. Am I right? The data frame only, right? The name is, no data frame. X you can print actually. I'm printing feature and polynomial feature. Good. Can I ask a question? What is the degree level? How much I have given? 1 I have given, right? Yeah. What is the next example? 2. Degree 2 I am giving actually. The next example will be, talk with me, sir. 2. Degree 2. Follow the running notes. Every example in detail I'm just trying to sharing here. Come on, let's do actually. Then what is the use of creating this polynomial feature? Hold on, sir. Hold on, I will tell you. Feature number 1. Talk with me. Feature number 2. How many features? 2 features. 2 features. Are you ready? Now, the next step will be, sir, let's do one thing. Now in our hand, features would you have, polynomial features would you have, it's the right time. Create a model, train your model with polynomial feature. Train your model with, that is called as a polynomial regression. That is called as a polynomial regression. Come on. Now that step you need to be understand. Step number 4. Splitting the data set, it is an optional. Why optional? Yeah. Step number 5. Model creation. Step number 5. Model creation. Yeah, come on, sir. Linear regression, you can create a model. Yeah, we are get ready. Now, step number 6. Chaptara, can somebody tell? Model training. Chapter with polynomial feature. Very good. Let me highlight actually. That's what you need to be understand. Model training means we know. When I say only model training, normal feature. But here it is not a normal feature, sir. It is a polynomial feature. Model dot fit method. Chaptara, do you think x comma y? No. What I need to provide? X underscore poly. And here we need to provide. Now this model is called as a polynomial regression. That model is called as a just a feature names. Now what we done is we have created a polynomial features. Look at the topic name actually. What is that one? Polynomial features. With polynomial feature, if you train algorithm, that is called as a polynomial regression. That is called as a polynomial regression. Come on, let's do that actually. Good. Model training done actually. Now let me show you the impact. Forget about the prediction. We are going to do actual. Then we should get a right prediction. We should get a, team, are you with me? We should get a right prediction. Good. Hold on. Yeah, we have trained actually. Sir, any idea what is this? Plotting. Let's plot. You will get a clarity. More clarity you will get actually. Let's plot. It's okay. Again, special step number 2. Special step actually. Special step. What you are doing, Daniel, actually. So simple data visualization I am doing. Data visualization. It's okay then. Come on, let's do actually. Matplotlib is required as usual. Do we have that library? Yeah, Daniel, would you have? Then create a scatter plot as usual. First of all, existing data, try to create a scatter plot. We are creating the scatter plot. Then it's the right time. You can just have to call these are all. We already know this. We already know this actually. Good. And let me just have to create a image. Yeah, man. Data is traveling like a curve shape actually. What shape, sir? Now, let us just have to create this one. Make a note on this. Plotting. What we are doing actually? Plotting. One small point I wanted to talk with you. Here, model. Polynomial regression model. What model? Polynomial regression model. To do the prediction, you have to provide polynomial features only, but not normal features. But not, sir, you trained a model with normal features. Just try to provide for prediction, normal features you can provide. But you trained your model with polynomial feature. While doing prediction also, you can do prediction by using polynomial features only. By using what exactly? Yeah, that's what I'm saying. Model dot predict of, it is not a X actually. It is what exactly? Polynomial feature. What is that? Why I'm highlighting these many times, a small, you may get a confusion. That's what I'm highlighting. That too, what is the degree level I'm taking actually? Let us start from 1. We'll see the diagram, so we'll see the diagram one by one actually. Quite interesting, sir. Polynomial features, comma, degree value. How much a degree, sir? 1. Yeah. Let's run this example. You'll get a clarity. Come on. First diagram. Can you tell me what is the degree value? 1. Okay. Daniel, let us copy. You can kindly remind me. Today I need to upload these 2 images. These are all images I need to upload. Let us make it like a 1. Cinema shot. Instead of 1, Daniel, can I make it like a degree 1 actually? Is it okay for you? Degree 1. Sir, let us provide degree number 2. Now, are you ready? Can I run the example? Look at the diagram. What happened? Yeah, previously straight line. Previously, now almost the line is going to fitting for the data. Here, what is the impact parameter? Talk with me. Yeah. Now, yesterday I told, right, read 2 to 3 times actually. Degree, that is really matter here. That really matter here actually. Good. Did you notice actually? Image automatically changed, sir. What is this value? Degree 2. What is this value? Degree 2 actually. Degree 2. Go back and you can just have to come here and image actually degree 2. Talk with me. What is the next step? Yeah, let us provide degree 3 also. We can see. Look at the data. Nice, man. Almost, the line is fitting over the data. The line is fitting over the data. But yesterday, straight line. Yesterday, what line, sir? Straight line, actual. Straight line. Let's just have to save this one. And I can make it like what exactly, sir? Degree 3. All right. The next one, if you want, let us provide for 4 also. Let us provide what exactly? 4 also. I mean, we are creating the features immediately. With that features, we are creating the model. Such a nice discussion actually. Wow. Look at the output actually. First of all, creating the features. With that features, what is that feature? Polynomial feature. We are training the model. You are training what exactly mean? Model. With that model, we are doing the prediction also, and we are getting this result actually. Almost enough. Now you can go back. I will tell you what is happening in the behind. Sir, no jantar mantar. Understand the code actually. I will tell, sir. That I'm going to tell actually. Now itself only. Yeah. This one is how much value? Degree 1. Degree how much actually? 1. Sir, with the degree 1, not much impact actually. Now just try to move on with the degree number 2. Okay, very good. Somehow you can see actually. On an average, the data is traveling like a curve shape actually. The line also, it is not like a straight line. Curve line actually. What line, sir? This one is almost near to the right fit. This line is really to the right fit actually. Let us just have to fine tune. I mean, you can just have to move to the next level. Sir, what is the best line? The best line in the sense, the line supposed to touch, the line supposed to be nearby all data points. The line supposed to be nearby all data points. See, maybe for this data point, this line is near, but what about this data point? Somewhat far. What about this point? Somewhat far. Even this data point, and this one is satisfied actually, but other data points not satisfied. Then you have to look, you have to understand the diagram. Look at the third one. This one is a degree, how much level? Let us provide 3. Somewhat very near, like a snake actually. I'm sorry. Are you with me or not, sir? Children, almost the line is as close as possible to all data points actually. But one point, let me tell you. You can just to move to the next one. And this one is what exactly, almost. Frankly speaking, this one is a somewhat right fit actually. Somewhat what exactly? Right fit. Now let me tell you. Whenever you are looking at the data, first of all, the data should be nearby data points. One small condition, that condition will be that line should not touch the data points almost actually. If you are touching the data points, it means to say that indirectly you are overconfident. The topic is called as overfitting actually. Your model is telling, I will do the right prediction. I will do right prediction actually. What I mean to say that is, previously one student asked a question. Hey Daniel, can I give 10 value? Can I give what value? If you are giving 10 value, what is the problem here, sir? Your line will touch all data points, which is not a good practice actually. Chudandi ikkada. Can anyone give a kind of some guarantee? I will do the right next to data point. Can we give a complete guarantee? Nearby we can tell, but not complete actually. Then indirectly, you have to provide the optimized value. Degree value equals to 3 or 4, you can proceed actually. With the degree value is 3 and 4, you will get a, what I can say, probability value. Probability in the sense, guessing good value actually. Chances are very good actually. Sir, you got it, I guess actually. When you're talking about the degree, still you can provide 10. But this model is called as a overfitting model. What model? What do you mean by overfitting? Upcoming topic actually. Let me show you. Underfitting and overfitting. Here you can see. Yeah, underfitting and overfitting actually. I'm sure, I hope you understand. Then I need to add, these are all examples. Sir, by looking at the data only, by looking at the image only. By looking at the image only. First of all, let me include an example. First, I need to add for degree equals to 1. Here the degree equals to 1 actually. Next, degree equals to 2, I need to add. Next, to degree equals to 3, I need to add actually. Sir, we covered these are all examples. Kada? Question. There are 2 questions. Counter question. Daniel, what is the best value? For degree. Next question. Can I give? Why? Because if I'm increasing the value, automatically what is happening? Model is fitting to the data actually. Can I give a kind of some 10 value? 10 value actually. Now let me tell you. First point, we need to check by using data visualization. What do you mean by best fitted line? Best fitted line in the sense, line means, what do you mean by best fitted line? The line which is nearby the data points. What exactly, sir? Data point. That is called as a best fitted line. I'm sorry, man. That is called as a best fitted line. Imagine there is a line. It is passing through all data points. That is not a best fitted line, sir. That is called as a overfitted line. What line? Overfitted line. If we give degree 10 actually, degree what exactly? 10. First point. Diagram looks pretty good. Looks what exactly mean? Pretty good actually. But that is not, that is not the right way. Not a good value actually. Not a what exactly good value. This model is called as a overfitting model. What model, sir? Overfitting model actually, overfitting model. If you want, I will tell you one small point. Can I tell you? Sir, whenever you're talking about the regression, either normal regression or polynomial regression, ensure that you're having the data points. You're having, these are all things like, data points actually. Imagine, let me tell you, this one is a data point number 1, data point number 2, data point number 3. The data travels like this actually. Think like this. The data is traveling like this. Then don't think like this one is the best line actually. Line number 1 here, line number 2 here, line number 3 here actually. I'm sorry, this is not a best fitted line. Now I hope you got a clarity. What is the best fitted line? The line supposed to pass through nearby or as close as possible to the data points. As close as possible to that. This is called as a best fitted line. This is called as a best fitted line. Make a note on this one. But now let me tell you, Daniel, okay, we understand the data is traveling like this, so here is the data traveled like this actually, travel like this, like a curve shape actually. What shape, man? Curve shape actually. Now don't think like it is touching this data point, again next one will be this data point, again this. No, sir. This is not a good line actually. This is not a good line. The line is supposed to be passed through near to all data points actually. Are you clear about this? Right. Now let me just try to pass here. When you're talking about the line is supposed to be passed through, that is okay. Nearby actually. Almost all that is okay. If it is crossing also fine. That is still fine actually. Cool. Hope you understand. Let's move on. Now, yeah, tell me, sir. Which one? Fit and? Good question, boss. Difference between online team. I have seen one question. Please hold on. I will tell you. Fit and what exactly? Fit underscore. Fit underscore transform, right? Tell fit underscore transform. Point number 1. Fit method belongs to machine learning. Belongs to what exactly? Machine learning, especially for training. Especially for what exactly, sir? Training. Fit underscore transform. It belongs to feature engineering technique. What technique, sir? Feature engineering technique. Both are different. Feature engineering technique. This is for creating a features. Creating what exactly? Feature. That's what you need to be understand. Okay. Good question. Online team, I have seen one question. So let me check this question. Nageswara sir, sorry if this question is not a valid no actually. No sir, no need to be sorry. We can have this visualization for 2-dimension data. If the data is having the more dimension, then how to decide degree value? Then we have not able to. Yeah, good sir. Sir, great question, sir. First of all, let me tell you. Nageswara sir is asking, Arey Daniel, if the data we are having the, if you are having the 2-dimension, a line is fine actually. Now here is the story. A small points we have to be understand. What are points, everybody, important points. Sir, if it is a 2-dimension data, then here line, so here line works well actually. Here we need to create a line. We need to create what exactly? Create a line line. But you know what? If it is a more than 2-dimension actually, 2-dimension data, then we need to create a plane. We need to create a plane actually. Plane. It's not like a PLEIN. Especially this I will cover during SVM actually. During SVM. Sir, hope you got a clarity. Yes, of course, 3-dimension, 4-dimension, 6 dimensions also we do have. During that time we need to create a plane, not a line actually. What do you mean by plane? If you want the data separation, go to the SVM. Where is SVM? Support vector mission. Look at my screen. Here the first two data and second data category it is operating by using plane, but not a line actually. Are you clear? That in middle, what exact plane means? Flight wing. What exactly, sir? Think like flight wing actually. Okay, exactly look like this. More separation actually. Okay. We can do. These are all during SVM I will cover. I hope Nageswara sir, is it okay for you? Yeah. Okay. Sir, we created a polynomial feature. We created a polynomial regression model. It's a right time. What is the next step? Prediction. What is the next step? We should get a right prediction now. We should get a, let's do actually. Let's do for prediction. One important point I'm going to cover now actually. Let's do for prediction. Degree 3 I have given. With the degree 4 also I tested actually. Here more on diagrammatic representation, sir. But I cannot say, sorry, this line is not up to the mark. Why? Because it is touching almost all data points actually. If the line is touching almost all data points, that is not best example, sir. Can I tell you one small point? Think like all these data points are homes actually in a village. If you wanted to construct a road supposed to be nearby home, but not touching the home actually. I hope I am clear, I guess. Best example for, best fitted line will be, think like a road actually. What exactly? Road, a pathway. A pathway is supposed to be nearby home, but not touching the home actually. Make sure. Yeah, predicting the result. This is quite interesting example. Let me talk with you. Ayyo. Let me talk with you. Good. Daniel, almost these are all data visualization is not required. Out of these are all. Good. Let me delete these are all. And model also trained actually. And yeah. It's the right time for prediction. It's the right time for what exactly, sir? Prediction. Chapandi. Prediction. Good. Talk with me, sir. How to do prediction? Chapandi, can you guess? Model dot. Okay, hold on. Model dot. What method I need to call? Predict. And for what value I need to provide? Can you tell me what is the value? Excellent, ma'am. Here, if you are providing 6.5, I am again telling you are doing the wrong actually. You are doing what exactly, sir? Wrong actually. Only one madam, she already tried actually. Sir, if you are providing here 6.5, you are providing feature. You are providing. But what is a model? Polynomial model. Though polynomial model, even first of all, you trained with polynomial feature. While doing prediction also, give polynomial feature only. Come on, let me be more clarity actual. Sir, we created our model with polynomial feature. What feature? Yeah, are you doing prediction actually? While doing prediction, please provide polynomial feature only, but not normal feature. But not, here is the story. 6.5 is the feature. How to create a polynomial feature? How to create a polynomial feature? Yeah, exactly, boss. What we need to do? You can just have to come here, use this object. What object actually? Polynomial regression. Call this method. What is the method actually? Fit underscore transform. I mean to say, yesterday I already covered actually how to create a polynomial feature. I mean to say, instead of providing 6.5 here, what we need to do, polynomial feature object name dot fit underscore transform 6.5 we need to provide. Come on, let me show you. Daniel, can I provide directly like this? No, sir, it is a wrong actually. Why? Because we should not provide. We have to provide. We need to provide. We need to what exactly provide? Polynomial feature. What feature actually? Polynomial feature. Make a note on this. Make a note on this. Many students are getting confused here. Daniel, how to create a polynomial feature? Print of Chaptara model dot predict method, and here is the story. Go back and get the data. Object name dot what is the method name? Fit underscore transform, and here you need to provide like array data. What data, sir? Array data. We are good to go. We are almost very near actually. 6.5. Now, can you guess what is the expected answer? What is the expected answer, sir? In between 75,000 to, I'm sorry, 1,50,000 to 2 lakh. Am I right? Let's just try to get that result actually. Online team, I have seen one question. Please be on the line, sir. I can take control actually. Yeah, good. Now with, so with polynomial regression, what regression? Polynomial regression. Polynomial regression. Let's do the prediction. Prediction value, right? So, model is going to predict. Are you ready? Can I run? Good. We should get a right value. Very good, man. And the 1 lakh. Your expected answer will be 1,75,000, right? 1 lakh? That is okay. Sir, equation problem. Are you with me or not, sir? That degree, how much I have given? Endichano? 3, yeah? Okay. 4 I have given actually. You can increase the degree. That is still okay actually. But hold on, here we are doing degree with 4 actually. That is still okay. But let me tell you, sir, 1.1 lakh 58 lakhs is the decent actually. I can tell to that employee, sir, show your performance, I can increase your salary. Are you with me or not, sir? Okay. Hope you understand. Take this one, and I can say this one is so very good. I know your expectations actually. Model is telling Daniel, fine, that much salary is fine actually. Let him work. Let him work later and we can see actually. What is the margin? How much almost missing actually? 1,75,000 మీరు expect చేశారు కదా. On an average, I can say 12,000 is the difference. It is okay. 75 you can ignore actually. Around I supposed to give 70,000, but 12,000 is the difference. Indirectly the profit for the company actually. Okay, na అర్థమైందా సార్ మీకు? Okay. Now let me tell you, sir, I cannot say best prediction, good prediction. What prediction? Yeah, this one is a good prediction and right prediction, sir. Right prediction actually. Did you understand or not, sir? Okay, you can you can try, sir. Degree equals to 5, you can try, and it's a right time. Let me. What is a major step here? Many students are getting confusion. Daniel, why you are providing here actually? I'm sure you got a clarity. First of all, you trained your model with polynomial feature. Then model knows only polynomial data. While doing prediction, you can feed with polynomial data only, but not normal data. But not. Are you clear about this? Okay. చెప్పండి. That's what, sir. So even from the diagram, you need to look at that actually. If you are giving 2, the diagram looks like very, low. That's what I told previously. Even if you look at the diagram. Yeah, exactly. Underfitting, overfitting topic, we have to be aware. If you are looking at the degree 2 actually, I cannot say this one is the best fitted line. I cannot say this one is the best fitted. Again, we may get a wrong prediction actually. We may get a wrong prediction. This one is somewhat near prediction. This one is somewhat good prediction actually. Okay, make a note on this. Now team, I'm looking your questions. Siddiq sir, think of data points as a home is a village and the line is a road. Okay, Charan garu, let me take your question. Siddiq sir, nice explanation. Charanji, Are Daniel, fit is already done. Fit for polynomial feature. Then why again actually? I'm sorry for telling. Please make a note on this one, sir. This fit is different. This fit underscore is different. Don't get it confused. If you really yesterday, you can just try to understand yesterday example actually. Did you attend yesterday's session? If you wanted to create a polynomial feature, you need to call fit underscore transform. Both are not same. Are you clear or not, sir? Make a note on this, right? Fit is different actually. Fit underscore different. This one is creating this is belongs to feature engineering technique. This is belongs to model training actually. No response from Charanji. Are you clear or else? Sorry for saying, sir. You didn't understand the topic actually. First point be clear actually. First point be clear about what is feature engineering, what is model creation. First of all, you are not clear about the feature engineering and model creation, then generally these questions are very common actually. Are you clear about this? Other guys, are you clear? Charanji, I am repeating again. When you are calling fit underscore transform actually, fit underscore transform. It is called as a feature engineering technique, sir. Feature engineering technique actually. But anyway, let us make it more clear. It's not training purpose. It's not what exactly training purpose actually. Training purpose. But whenever you are calling fit method, this is for, not a feature engineering technique. Not a feature engineering what exactly technique. It is for what exactly training purpose. Please be clear about this one. That's what I'm telling. Revision helps you, everybody. Otherwise, it leads confusion. Please. Okay. Maybe one more question also I have seen somewhere. Piyush Garu, where is your question? Good, all right. Fine then, and hope you understand. Can I get a response from you? Sir, did you understand, everyone? Yeah. This one is a big topic. Yesterday we started a cinema and today it got end actual. So ensure that, you have to practice many number of times. There are some logical points would you have, you need to understand this one. Sir, simple. Either linear regression or polynomial regression depends upon the data. If the data is a linear, go for linear regression. If the data is a non-linear, go for the what exactly? Polynomial regression. Polynomial regression means don't expect the new algorithm, same algorithm only, but we need to train the algorithm with polynomial features. We need to train our algorithm with polynomial features. That's what we done actually. Okay, polynomial regression prediction output will be 3,30,000. Oh my God, very high salary actually. And I'm sorry, linear regression output is this one. Polynomial regression output will be, anyway, we expected 1.75. That is okay. I can give less salary. What is wrong in that actually? Polynomial regression prediction output is almost somewhat good according to the discussion actually. We are getting in between actually. That is okay and accepted output. Did you understand or not, sir? All right. There are some factors. Daniel, why exactly we didn't get 1.75, 1,75,000? First 2 point, we have a small data. First point, would have a, if you want accurate results, we have to feed with more data. Point number one. More data, more accuracy. Talk with me. If you want to do one thing, you can just have to increase some 30 to 40 levels. You can just have to try. You will get an idea actually. If you are increasing the levels, then you will get a, more data, more accuracy actually. Ensure that, make a note on this. Okay. Good. No, back to the session. Charan Sarji, I'm sorry, I'm sorry if I'm stating wrong. Sorry for asking. You didn't. You in the sense everybody actually. I mean, if so other guys also, others also didn't understand the topic. If anyone having this kind of question, actually make a note on this one. The point will be clear. What do you mean by that actually? What is a feature engineering? What is a machine learning? Can I tell you one small point? Let me tell you. Go back to the Python. There is a method so called as a count. String also having, list also having, talk with me, tuple also having. Do you think set having? No. Go for pandas. There is a method. Method name is a count. Talk with me. Series. The next one will be data frame. Now, don't think just to method name is matching. Functionality is the same actually. No, it is not same. Please, you have to be clear actually. Sir, method name same, I will accept actually. But functionality is the different actually. Count method. Finding the duplicate value. Finding the frequency in a Python. But when it comes to pandas, no. All values excluding. Make a note on this, right? Just the method name is matching, so, but functionality is different. Conclusion of the story. In a feature engineering, fit underscore transform, both are different, sir. In machine learning, fit method. Fit and fit. Think like count on count actually. The good news will be we done. I mean, the topic is done, not the session actually. Okay, good. So with would have a with an enough time. What topic we can close very quickly, there is a topic. The topic name is called as a. Where is one hot encoding? Can somebody help me? Yeah, very good, sir. Dummy variable and one hot encoding. Sir, first of all, this topic again depends on simple linear regression. Again depends on simple linear regression. What we are doing is we are going to take a ML algorithm. For ML algorithm, it need numerical data. Madam, what data? Numerical data. But unfortunately, we have a data set. The data set contain numerical data plus categorical data also. Categorical data also. Now let me tell you, go for simple linear regression. We can do price prediction, a kind of some area prediction, which is called as a price actually. Price depends on area. Price depends on, when I say area, so and so square foot, 2000, 3000, 4000. Sometimes not only area, sir, it depends on location also. It depends on location also. That really matter. Now that location is the categorical variable we are going to take actually. Now how to handle this scenario? I'm going to cover. First of all, are you clear about the problem statement? Let me tell you. Let's move on. Okay, let me show you the data set. Go back and let's just try to get the data set. All files and home prices too. I don't want more separations as of now. So think like I have taken the data like this actually. First of all, this is completely belongs to Krishna district. I mean to say Andhra, Vijayawada, Guntur, Gudivada actually. These are all nearby locations. Now this is the town. Previously we done, this is exactly simple linear regression. This is exactly. But let me tell you, this one is a feature, sir. This one also feature. Town also feature. Town also feature. Now this one is a categorical data. What data? Now let me tell you, ML algorithm need only what exactly? Yeah. Now in feature engineering, we already covered one step actually. That step we are going to use today, so that you will get a clarity actually. Are you clear or not, sir? Let's move on. Let us take a Vijayawada, 2600 square foot, 5,50,000. Like Vijayawada street number 1, street number 2, street number 3. Think like that actually. Again Guntur. Again what exactly? Gudivada. These are all Vijayawada nearby my home actually. Even Guntur, Gudivada also. Fine then. Okay, hold on. Imagine I have given this data set actually. First 2 point what you can do, you can create a data frame. You can create a, once you create a data frame, what are the operations you can apply? మీరు ఏమేమి అప్లై చేస్తారు దీని మీద? Head you can apply, tail you can apply, shape you can apply, columns you can apply, count you can apply. Any other? Checking? Null values very good. Any other? Data type you can apply. Any other? By looking at categorical data, first you need to tell, what you need to tell, sir, filtering the data. What data? First of all, how many unique values? 3. What is the first one? Vijayawada, Guntur, Gudivada. Yeah, you can apply group by. You can apply. Are you with me? Make a note on this. Looking at the data, you have to map to the all pandas operations. What are all you can apply? Unique you can apply. Based on that unique, I wanted to separate Vijayawada data frame separately, Guntur data frame separately, Guduvada, like a filtering you can apply. If you want still, you can go for group by you can apply. Many things you can apply. You can apply sorting technique. Okay. No, sir. You guys are not good in, preparation actual. I don't know. Let me tell you. If you done 10 times revision, how many times revision? Then go for interview. How many revisions? 10 times. If you done one time only, one time revision, 10 times revision actually, 10 times revision. One time revision. I request you, sir. I request you. Even if you attend, literally you will fail actually. You will fail the interview. Not only failing interview, I'm sorry. I should not use this word, but this one is an open fact actually. If you are preparing only one time, first of all, you will get a confusion. First of all, you will get a confusion. The next one, you will get a fear actually. Because of these two reasons, you can fail the interview. You can fail what exactly, sir? Interview. Make a note on this one. If you done how many times revision? 10 times. Go for interview. I'm sure you will give left and right actually to the technical person. But Daniel, I have prepared only one time. If you done one time revision, can I attend interview? I request you, even if you attend interview, even if you attend what exactly, sir, interview, literally you will fail. No doubt in that actually. For me it happened. Once upon a time when I was learning Java actually, I was little overconfident. I thought like I prepared one time. I thought like I know everything. I have given an interview. Almost 2 to 3 interviews I failed because of my, so lack of practice. You don't face that scenario actually. Do you wanted to attend? Do you wanted to touch the interview door actually? Are you cross question? Are you ready? 10 times are you done preparation? If you are not done preparation, don't give interview actually. I'm sorry. Are you with me or not, sir? Good. Conclusion of this story, what I mean to say that is, Chiptara sir, what is the conclusion? Wherever you go, I will come from that. Do more practice. Even I raise my voice, I can keep low my voice. I will always talk about practice. That's it. Then I'm happy. Purnako satisfied actually. Are you with me or not, sir? Good. Make a note on this. Man, these are all open facts. These are all open facts. There is a great question actually. Sir, first of all, great question. Great question. Now my answer will be each line from our material actually. Tell me. Each line. Sir, each line from our material. Then only you will get a clarity. Can I ask you one question? Can I ask you one question? Let me tell you. Sir, when I was in 3 years of old actually, 3 years of what exactly? Old actually. Let me tell you. A to Z, how many? A to Z, how many? Sir, 26 is really burden to remember for me. I don't know, I was unable to remember. Then can I ask a faculty, please? Can you accept actually? I was unable to prepare. Can you skip the few things actually? What trainer told? Teacher have taken this much long stick actually, right? And she told, you have to prepare all 26. Don't miss not even single point actually. That's the problem. So generally the student's psychology will be, sir, we are all habituated from academic learning. What learning? Don't apply academic practice on the, if you wanted to enter into the IT world, if you wanted to get a job actually, there is a process. Follow the process. With experience, I'm telling. Even for me, let me tell you, 10 is a small number. 10 is a small number. First 2 point, sky is the limit for practice. Number of times do the revision. I know one student, maybe I already told actually. His name is Shakti. He's from Bangalore location. Are you, sir? Maybe did I told this one with you? Oh, seriously? Then let me tell you. There is a person name is Shakti Prasad. He's from Bangalore. And 2019, he is my student, especially big data actually. Those days I used to teach PySpark. Those days I used to speak, I'm a big data trainer also, but I left that one. Why? Because, I would like to teach always cutting edge technology. Then one day first of all, let me tell you his background details. He is from BCom distance, sir. Can you believe actually? BCom distance actually. BCom what exactly? Distance. Distance in the sense, till intermediate he is the regular. Then because of his financial condition, he joined in some company. He's working like a tech support guy actually. What support? Tech support. Then parallelly he continued degree. In distance he finished actually. Now in Bangalore there is a one good institute I used to teach there. Then after he's done graduation, and one day he came for my demo. Then he explained his profile actually. Proudly I can say, currently he is working like a data scientist actually. Make a note on this one. Let me tell you. One day what he asked, hey Daniel, I wanted to become big data developer. What developers are actually? Big data developer. When I say PySpark, team, Python is required, Spark is required. What is the Spark? We can see later. I wanted to become a big data developer. This is my dream actually. Sir, just I told only one thing. Just I told us do 100 times revision. You can't believe the same statement I told actually. I'm sorry. Promise I'm telling. How many times you told? 100 times. Then he just smiled and he didn't even reply also. He smiled and he left. Sir, you can't believe. After few months actually, after what exactly few months, and he called actually. What exactly, sir? He called. Then straight away he is telling one thing. Daniel, from our material, ask any question. Ask what exactly, sir? Any question. Sir, let me tell you. First of all, material created by me. Somebody came and he is challenging. That is proud moment for me actually. And he is telling, ask any question from your material. First question what I asked, sir, explain about the constructor. Ayo, you can't believe the way how he explained, sir, more than me. He explained very nicely. Every statement, go to the constructor material. First point will be, constructor is a special kind of method. He started the cinema like that actually. Till to the last he started explaining. Almost 10 minutes explanation he has given. I feel goosebumps actually. Why he shined? Why? Because what is the story actually? Talk with me, sir. 100 times revision. Conclusion of the story, more revision, you can gain more subject actually. That's what the problem with the students. You will do 1 or 2 times preparation. You will expect like, sky level result actually. How you will get, sir? That day I told, sir, next level of preparation. He still used to touch up with me. Such a great guy. Great guy. Conclusion, become distance, sir. He prepared in such a way that he is giving left and right actually. Let me close the discussion. The point will be, sir, more practice and you can get job very quickly actually. That's what I wanted to tell. Am I doing overaction? No, these are all open secrets. No one ever deliver actually. Open secrets. మీకు తెలుసు కానీ తెలియనట్టు ఉంటాయి. Online time. I'm sorry, sir. Did I disturb you actually? Oh, what is the material? PySpark. Proudly I can say, I'm not boosting myself. In Bangalore, I'm the one who teach PySpark actually. Which one is a big data cutting edge technology? You are not aware. Let me tell you. Power of our material will be, you can just try to go for, what is my name? Yeah, Nirikshan. Search with my original name actually. Nirikshan kind of some PySpark material. It will relate to almost all websites actually. Yeah, this is one of. Fine then, let me close. These are all. Let me drink water, please. Back to the session. Thank you for, so these are all, sir. I feel so happy if you gain the subject actually. That's what I wanted to talk with you. Where are we? Let me just try to delete. These are all, what are not required, I can delete actually. And okay, this might be helpful. Instance methods he is telling actually. In Java also same concept. I'm sorry, online team, hold on. Tell me the instance variable definition. Oh, okay. Come and tell me. Okay. Okay. Very good. That's the level of your preparation actually. When I'm asking about the instance variable, you have to exactly, you need to, if the value of the variable is changing from object to object, such type of variables are called as a, sir, that flow matters. If you are unable to deliver that point, no, sir, you have to do lot of times revision. Anyway, back to the session. I'm talking with you, today in such a way that more revisions, man, more revisions actually, so do more preparation for our material. Back to the session. Thank you. Now the topic name is called as a dummy variable and one hot encoding. What is the topic name? Dummy variable and one hot encoding. I hope you already show the data set, and let me show you. First of all, let me explain about the categorical data. What data? Categorical data. Now what we are going to solve by using this one, what we are going to solve, Daniel 3400, and what is the location? 3400 ML algorithm will understand, but ML algorithm cannot understand one value. What is that value? It cannot understand actually. I'm sorry, let me talk with online team. Online team, are you clear till now? I hope my words helpful for you, sir, actually. Rishi Sarji, yeah, I was in Bangalore around 8 years, sir. But one mistake I done. I was unable to learn Kannada actually. I like that one, but I didn't focus on that. Only that mistake. 8 years I stayed in Bangalore. All are surrounded with Telugu only. I'm sorry. Any question from anybody? Vagdevi Vilas Martali. Rishi sir, good sir, very good. And even in Bangalore, there is one college, CMR college actually. While you are moving from Martali to Whitefield location, there is a CMR college. I have given many sessions actually. Okay, please. Categorical data, we already know. So let me tell you, when you're talking about the categorical data, nominal data, next one will be ordinal data. What do you mean by nominal data? Very good. From our material, exact sentence will be no logical order. What is that? No logical order. The next one will be ordinal. What do you mean by ordinal? Logical order. We cannot keep Gunturu, Guduvada. I'm sorry, these three locations we cannot keep. There is no order actually. The next one, male and female. Can you tell who is the first actually? Third World War will come, sir. What you are thinking actually? I'm sorry. I am telling with my experience. Green, red, blue. No order actually. But still what we can do, we can keep with some alphabetical order. But no use actually, right? But let me tell you, satisfied, neutral, dissatisfied. Talk with me, sir. Graduation, master, PhD. High, medium, perfect. How to handle text data in a town column actually. Here is the story. Here town column having the text data. How to handle text data in a numerical model actually. Good. We'll do one thing. What are all scenarios we'll have, I will explain one by one actually. Model may, now let me tell you, these are all values we have. What are all values, sir? Vijayawada, Guntur, Guduvada. Let us apply ordinal encoding. What encoding? What do you mean by ordinal encoding, First of all, no order. We are bringing forcefully into order actual. So conclusion of this story, think like I am giving Vijayawada as a 1, Guntur as a 2, and Guduvada as a 3. Now here is a problem. What is the problem, if you are giving 1, 2, 3? First of all, Vijayawada. How much value? The next one will be, talk with me, sir, Guntur. Guntur value 2. The next one will be Guduvada value. What value actually? Guduvada value 3. Now here is a story. Here we cannot compare, but here what we can do? We can compare. Back end what happened, ML algorithm will understand. 1 plus 1, what is the result, sir? Back end it will understand. If I combine Vijayawada plus Vijayawada, what is the result I'm going to get, sir? Guntur. It will understand like that as well. Misunderstand. Are you with me or not, sir? Anyone is from Vijayawada, Guntur? Oh, good, sir. Good, actually. Very good. Very good. Fine then. Now, numerical value we can compare. But categorical value, what exactly we should not compare actually. Then I'm sorry, this technique will not work in this case. But this technique works in a separate case. I will tell you that one later. The technique what I have explained, like convert the categorical data into numerical data, it will not work here actually. Then go for the next best technique, which is called as a one-hot encoding. Which is called as a, don't ask what is one-hot encoding actually, right? We already done. We can convert the text data into numerical and can proceed to the next step. Vijayawada, Guntur and Gudiwada actually. If you are giving the data to the model, then the model assumes that, there is an order 1, 2, 3. 1 less than 2 less than 3, right? Then location number 1 less than location number 2. Sir, literally wrong actually. Frankly speaking, this one is a very big place compared to this one. Even, Guntur is very big place compared to the Gudiwada actually, right? And even to get a 3, 1 plus 2. What is the 1 here actually? Vijayawada plus Guntur. Literally wrong statement actually. Backend kind of some starting comparison, kind of some math calculation, it is happening. To overcome this problem, we need a dummy variable one-hot encoding. Are you with me? Dummy variable one-hot encoding. If I start now, all right, so it may take some time. Let me stop the session now. I hope you are clear. On small suggestion, do more practice, man. Do more practice. Every point you have to remember actually, right? We done today's session. We'll connect again tomorrow. Don't waste the time, sir. All you guys are youngsters actually. Okay. Yesterday, polynomial regression. Go back and let us upload the same running nodes here itself actually. Why? Because no new topic here. Did you uploaded the data set? Did I miss anything? Either running nodes or PDF material or else data set. Did I miss anything? Tell me, boss. Yeah, thank you. Thank you. Please take care. Yeah, topic is yet to short, right? I can upload. I mean, though practice we are not yet sorted actually. Oh, images. Let me upload. Yeah, please, you can start. Let you go actually. Take care. All right, I have uploaded, sir. I have uploaded. Thank you everyone. Thank you for joining today's session.